I'm now going to give a presentation about the Met Center and the flagship project. And also, I will also tell a bit about other projects, because as Daniel told us about, there are a lot of things going on with floating, and we see it now that it's really exploding with interest from floating projects upcoming. This picture was taken out of a test center early August, when in the front we can see the HyWin, or now Unitech Zefyros, and in the background we can see the TetraSpar installed. The TetraSpar has not yet been put into operation, but it's only a few weeks ahead before the commissioning is done. There are two logos here because I'm also cluster manager of the Norwegian offshore wind cluster. And these two, the Norwegian Offshore Wind Cluster is a membership organization, but the test center and the cluster is connected to each other. And the reason to this is that we are coming after the research and the innovation. We are to the last stage where we are going to demonstrate the technology and to commercialize the technology. So that's why it's important to connect the cluster and this test center together, because we see that we can do a connection and building supply chains out of this new technology. So this Norwegian offshore wind cluster has 309 members. It's a doubling the last year. It's also saying something about the interest for offshore wind and especially floating wind in Norway at the moment. And we see a huge oil and gas industry who is looking for new opportunity. We see that the future is not as bright as it could be for the oil and gas industry, and they're looking for new opportunities. I see that the competency they have learned from the maritime and oil and gas can be used into floating wind. And the cluster is developing the supply chain, doing innovation, and also going into the market. But we also see that we are promoting development of a market for full-scale installations in Norway. And the Met Center, as a part of the cluster, has a purpose to contribute to drive down the cost and prepare for the full-scale part of it. As mentioned, there's a 1.5 gigawatt project upcoming in Norway. We see it with a red ring, and also we can see the test center is the green dots. Inside this red ring is the test center, so they are located in the same area. That means that the experience you gain from the testing demonstration can be used for the full scale. And also, what's also I can add to what Daniel told is that the government has now started also and have announced that they will start a process to look for more areas where also floating can be used. So, going into the flagship project, which is the main topic today. The flagship project is an Horizon 2020 project. Means floating offshore wind optimization for commercialization. That's the full name of the project. This project started in two ends. From my point of view, it started with a cluster, with a cluster company, Dr. Teknola Olsen, who has this technology. It has been, they have developed it for years. It has been tested in the wave tank at Sintef Ocean, and the next step was to have a full-scale demo to come to the next step. Dr. Teknola Olsen, they are a very experienced engineering company, coming specialist in concrete and coming from the oil and gas and the big condeep platforms in concrete in Norway. They used this competency and designed their floating foundation in concrete. On the other end, Iberdrola was looking into the same call and looking for a possibility and did a scanning of test sites and technologies, and we ended up with a collaboration. So this project ended up with 12 partners coming from Norway, Spain, Denmark, Germany, France. Our research institute, both DTU and SENA and Institute IHC are partners in the project. I can also mention that this project in the evaluation received 15 of 15 possible points as a score. So it had a very high score. So with these 12 partners, this project started 1 year ago. The project has 11 objectives. The first objective is to demonstrate the first floating more than 10 megawatt wind turbine. The plan is that this will be installed late next year. And then it will be 2 years of operation within the Horizon 2020 project. The second objective is to design a full-scale concrete semi-sub based on these patterns of Olav Olsen. And the third goal is to prove that this is feasible, this floating technology is feasible up to 20 megawatt. That makes it even more competitive. And number 4 is objective number 4 is to define and qualify a manufacturing process to to streamline the manufacturing and have it a very cost-efficient manufacturing. And concrete can be built on land and skidded out. It could be on barges or it could be in dry docks. There are several opportunities. And we see that also concrete has the possibility to set up temporary production plants and production areas for this. So the goal number 5 is to demonstrate that you can do also the installation very cost efficient using ordinary vessels. Number 6 is to see that using concrete you can also extend the lifetime. For the normal lifetime for a turbine is 25 years, but with a concrete you can do a replacement after 25 years and have maybe up to 50 years lifetime of the structure, and that makes it even more cost efficient and competitive. Number 7 is to decrease the levelized cost of energy. Number 8 is to reduce the carbon footprint compared to steel. Number 9 is to increase the social acceptance. Number 10 is to improve the operational and the monitoring systems. And the last one is to look into the future and see how the impact of floating wind could be. So there are a lot of goals in this project to bring the floating industry moving forward. So then I'm going a bit back to the test center, look into also other projects in the test center. And it started with a Unitech Hywind demo was the first one. Now it's Unitech Zefyros. It was owned by then Statoil at that time, now Equinor, and it was the world's first floating wind turbine. 2 years ago, there was a new owner, Unitech, cable supplier originally. They named it Unitech Zefyros, and it's now also open for third parties. It's open through a Norwegian catapult center established as a model of the UK catapult centers has been established to promote test and demo and to help especially SMEs. And now they have invested in this turbine, and it has been open for doing test of equipment, sensors and radars and all type of equipment which is needed to be tested on a live turbine. but it's also open for R&D projects. So that's something to be aware of in this here today. I can also mention that we had a very interesting visit in 2019, Makani. It was the Google Kite turbine, also a full-scale project on a spar buoy. Very interesting. They had that trials in 2019, but this is an example of a project where they after these trials decided to stop the project. So, I cannot, I don't know the details of why, but it's an example. And then I think we will see also this in the future. Some technologies have too high risk, I think. And I think this one here is, the risk was basically commercial. So TetraSpar has been installed this summer. It will be put into operation during the next couple of weeks. The owners, it's the Henrik Stiestad, one of the pioneers in the wind industry, is the inventor. Shell, RWE, and the Japanese TEPCO has invested in this demonstration unit. We look really forward to put this now into operation now. Flagship project is said. Next project, 2023, there will be another project installed, Swedish SeaTwirl, vertical axis turbine, 1 megawatt. Will be installed in a fjord because out in the oceans is too wave exposed. But the goal is to go to a bigger next step. So this SeaTwirl is coming from Gothenburg University and established as a result of the research there. Next one, also in 2023 is Hexicon. Hexicon, Swedish technology. 2 turbines on 1 foundation, also very different. So now we see that the technologies are going in different directions. So from my perspective, it should be very interesting now to follow who will be the winner in the future. We see that it's moving in many directions. So based on this, we are now extending the test center with more consents. We will have up to 85 megawatt at the test center. We are extending from 3 turbines, which we are consented now, up to 8, and also a new export cable. So, and we see that there's a really huge project. And actually, we have contracted one more, which I'm not able to tell about today. And we are in contract negotiations with even one more floating. And so there is a really high interest now for floatings. And last week we received 2 new questions about possibility to test. So this is. But what's also interesting at the test center now is the possibility to also do other type of research now. And we see there's a high interest now for research on the results on the marine life and birds. And we see there has been done a lot of research, but we also see that there's a lot of lot more and lot open questions, especially related to floating, to sound, and what do the noise do to the marine life, what is due to the spawning areas, and like that. And we are now looking into possible project to do this type of research here, where we have different type of technologies at the test center, and where we can do all this type of research. And one example here is we are testing of a new technology for birds surveillance. And this is a camera installed on this Unitech Zefyros, and we can see this I had a video here, but I don't know if it's starting. Here we can see the bird is upcoming, and the system is detecting it. It's metering the height, the distance to the turbine, and if it makes a collision, it will be registered. So, and also the next step of this technology is also to detect what bird is it. Now you can see it's a seagull, but it should be automatic, and all birds now will be counted in the future. Because if we are looking into the media, they say, okay, wind turbines, they're killing all the birds, they are cutting them into pieces and all that stuff. So here we can bring in facts into this debate. So and this type of research will be very important, I think, for also the social acceptance of floating wind. So I think maybe the time is running, but I can just say that about the mid-ocean conditions out at this test area, it's 9.7 meters average wind and 100 sever, and we have 12.9 HS with as a 50-year maximum. Okay, thank you very much.
Very good, thank you. So, thank you, Arvid, for a very nice presentation and also keeping time. We have time for a couple of questions. I think Arno was first and then Jake. So, Arno van Winningen from Frauenhof.
Yes, Arno van Winningen, Frauenhof Ivers. Thank you very much for a very interesting and varied presentation. I have, well, actually had several questions, but I'll just stick to one because to keep the time. You mentioned this, whatever it was, 12 aims that you have for the product, and number 8, I think it was the CO2 footprint, which of concrete is supposed to be reduced to 50% of a steel equivalent. Now, I like creative calculations as much as the next guy, but I'm really curious how you would actually end up with a significantly lower CO2 print for a concrete floater than you would for a steel one.
Yeah. I'm sorry that I'm not able to answer your question because I'm not the right person about this in the project. There are other partners in the project who are doing this type of. So I'm sorry.
Sorry, Lena, do you want to speak up? Maybe in the microphone? No. But of course, it's possible to reduce the CO2 footprint from concrete if you produce the CO2 cement without, with certain processes where you reduce the CO2 emissions. It's carbon capture and storage technology. Yeah. So Jake Badger from DTU.
Thank you. Yes, Jake Badger from DTU Wind Energy. Thanks. I thought it was very fascinating seeing the picture with 2 different types of floating technology in the same photo. But I wanted to ask you, in our sub-program looking at wind conditions and climatic effects, one of the other interesting things with floating wind is to be able to develop platforms for measurement and observation. So is that an activity that's also going on at this test center, or is it more exclusively testing floating technologies? So I'm curious about what other sort of measurement goings-on are there at the test center, LiDAR or floating systems.
Yeah. At the moment, these systems I have shown here. But what we have when we now are applying for new concepts, we are also applying for possibility to test, for example, floating solar and also wave energy. And we also see that there is an interesting also for combining wave energy and wind energy for some projects. We also see some interest also for hydrogen production connected to offshore wind. So we also have some questions, and also actually we also have a research application for a project related to one of for this Zefyros Unfortunately, we didn't receive that, but we have had several questions about possibility for that. So we hope to develop this type of activities.
So I was also wondering about the measurement infrastructure that's at the site.
Also you are thinking about measurement for wind and waves and like that. Yeah, at the moment, each project has their own measurement of wind and wave, but we have a collaboration with SINTEF and University of Bergen and some other, now an application for research infrastructure for this type. So we hope to have this received.
Thank you.
Okay. I would like to say to those online that they're also allowed to ask questions if they like. So it's just to post them in the chat and we will make sure they are read out loud and answered.
John, there's actually a question for Daniel.
Yeah.
But actually the online questions don't appear in Zoom. So maybe we'll tidy that up later.
Okay. Yeah. Well, I think we will wait with the questions for Daniel till a bit later. Okay, here it is something from Teresa Simons about the concrete. There are several potential and effective projects where the residual from the wind turbine blades are used in concrete and other composite materials. Do you have information on any advanced research on this?
Sorry, I struggled to hear your question.
Yeah, so the question was, do you have any information about advanced research on using blade materials and other as sort of a mixture into concrete?
I'm sorry, I don't.
Yeah, I don't think that's your area. So, but it's a very relevant question, and I think there is research going on into that area. So, okay, thank you again.
Thank you.